Welcome to today's webinar, Evolving Your Big Data Use Cases from Batch to Real-Time. Our presenter today is Steve Abraham. Steve is a solutions architect for AWS and has spent most of his career designing and developing enterprise-scale distributed systems for companies and organizations such as T-Mobile USA, the US State Department, and Hasbro. Most recently, before joining AWS, Steve ran an award-winning software development company based in Tampa, Florida. Today with us, we also have Guy Ernest, Business Development Manager, Jorge Lopez, Senior Solutions Marketing Manager for Big Data, and Prahlad Rao, Solutions Architect. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while our presenter presents. Steve, welcome. The floor is now yours.
All right. Thank you, Ryan. Thank you, everybody, for joining us today. Let's go ahead and jump into today's agenda. So for today's agenda, we will be covering some of the common use cases for real-time analytics, including some real-world customer use cases. We're then going to dive into some patterns and practices which will help you to support both batch and streaming use cases in your organization. After that, we're going to take a look at some of the tools available to you and take something of a deep dive on a few of those tools that you may find particularly useful. Once we've reviewed our toolkit, I'd like to walk you through a brief demonstration of an actual live streaming application. And last but not least, we'll set aside a few minutes for Q&A. If you have any questions during the course of the presentation, please submit them to our moderators and we'll do our best to answer all of your questions. So let's take a look at some of these common use cases. So the benefits of real-time processing apply to pretty much every scenario where new data is being generated on a continual basis. Looking at this slide shows a small sampling of different industry verticals, as well as some of the more common use cases in each. Oftentimes, customers start with simple log ingestion and processing applications, and these meet an immediate basic need. Over time, however, they progress to more sophisticated forms of real-time processing. Initially, customers may simply process their data streams to produce simple metrics and reports and perform simple actions in response, such as raising alarms when certain metrics have been breached their warning thresholds. Eventually, customers start to do more sophisticated forms of data analysis in order to obtain deeper understanding of their data, such as applying some machine learning algorithms. In the long run, customers oftentimes apply a variety of complex stream and event processing algorithms to their data. For example, the Twitter Firehose emits roughly 450 million events per second, which translates to a little over 10 megabytes of data per second. Customers apply machine learning to this event stream to identify public sentiment changes in very close to real time. Another example is customers that want to respond to changes in the stock market. Certain customers read from the NASDAQ Ultra feed, which generates roughly 8.1 megabytes of data per second and allows customers to make near real-time decisions regarding their stock portfolio. Some digital marketers produce upwards of 20 megabytes per second worth of data. These customers want to be able to analyze their data in near real time and respond to what customers are doing on various websites and apps. You can see a few of the other things that we have listed on here. We have IoT, gaming, and some of the different scenarios that you might see in those verticals as well. So some more specific customer use cases that we could talk about include Sonos. Sonos sells connected hi-fi audio equipment. Sonos's devices generate data logs which are streamed in near real time for ongoing analysis, which helps Sonos to continually improve their products. The Hearst Corporation analyzes more than 30 terabytes of clickstream data per day, which enables them to have real-time insights that they can share with their publishers. You know, we talked in the last slide about the 20 megabytes per second. Hearst is one of those that would easily exceed that. Nordstrom has developed a recommendation engine that, with the use of Lambda on AWS, has cut the time it takes to make recommendations from 15 minutes down to only a few seconds. They also moved from their on-premise data center into AWS and the entire application. Zillow is a company that I've worked with personally. Last year at reInvent, I had the opportunity to co-present with their Director of Business Intelligence, Brian Philpott. Brian was able to share with the audience how one developer was able to construct an end-to-end real-time data ingestion pipeline that leveraged the API Gateway, Kinesis, Lambda, S3, EMR, and Spark, which are all technologies that we're going to be talking about in upcoming slides. This developer was new to the AWS platform and was able to deploy a production able to deploy to production within 2 weeks. The final solution started by processing 500 million requests per month to start and has grown substantially since then. Let's move on to some patterns and practices. So when you're dealing with data, one of the first questions that a person has to ask is, what is the goal with this data? Sometimes it's not necessary to stream the data. Sometimes it is, and sometimes your business may have a case for both batch and streaming data. If the questions you need answered are largely historical in nature, then batch processing is likely sufficient for your needs. If you have a need to respond to events in real time or near real time, then streaming is a much better solution. When we talk about big data in particular, we're concerned primarily with two main features, velocity and size. When size is the dominant factor in your data, oftentimes batch processing is the better approach. However, when velocity is the dominant factor, stream processing might be a better way to go. We'll dig into the specifics a little more later in this session, but some of the common tools and protocols that you will come across in the data streaming world include Kafka, MQTT, Kinesis, Storm, Spark Streaming, and AWS Lambda. So, if it's been determined that you have a streaming need, then we should consider how best to process that stream of data. There are two main patterns that are leveraged for processing streaming data. The first is stream processing. This allows for real-time responses to events and data streams. Some examples may include fraud detection, inventory alerts, or possibly detecting device failure. Oftentimes, the main driver for such real-time analysis of this data is to provide corrective action in response. For example, if your software can detect fraud as it's happening, you have an opportunity to prevent it. If hardware issues are identified in logs that indicate that a failure is imminent, it may be able to stop the machine before real damage is done and notify an operator immediately. Another major processing pattern is microbatching. Microbatching provides very near to real time and for many use cases is indistinguishable from actual streaming real-time processing. The idea behind microbatching is similar to regular batch processing, except that the batches are significantly smaller and are loaded significantly faster. When we dive into our demo later, we'll see an actual implementation of microbatch processing. So let's review the overall data streaming design pattern. Moving from left to right, we must first collect the data, then process the data, and then finally analyze the data. It seems pretty straightforward, right? So notice as we move through the diagram that the storage medium for event processing, data processing, and analysis is likely very different from one another. So the reality is that in any given organization, it's rare that you will want to abandon batch processing altogether. So let's take a look at an architecture that supports both batching and streaming. This architecture is called Lambda Architecture. Please note that the term Lambda is very popular in the general computer science realm, and the word Lambda is very often an overloaded term. In this context, let's erase any connotations that we may have regarding the word Lambda, as they are unrelated to this architecture. In the Lambda architecture, we need a funnel. The funnel in this case is Amazon Kinesis. There are other funnels as well as including Kafka, but for our purposes here, we'll assume that we're using Amazon Kinesis. This is the landing zone for all of your incoming data. It's important to note that the data in this landing zone is immutable. You can only append data to this storage medium. Once the data arrives in the landing zone, we can move that data to our batch layer or data lake. A great tool to use here is Amazon Kinesis Firehose. We'll take a look at Firehose in more depth in upcoming slides and as part of our demo, but for now, what is important to know is that it can automatically read data from Kinesis and write that data to S3 or Redshift. Once that data hits S3, there are a number of tools that can be used to analyze that data, including, but not limited to, Redshift, EMR, Presto, Spark, Hive, and Pig. These tools can analyze your data in batch format and the batch type answers we discussed in earlier slides. For example, how many widgets did we sell last year on a month-by-month basis? While Firehose is loading data into S3 and Redshift, you can leverage the Kinesis Client library, or KCL, AWS Lambda, which is very different from the Lambda architecture, Spark Streaming, and Storm to build your speed layer. This is the layer that can provide real-time insights into your data and allow you to respond to questions like, which ad will be most appealing to this user based on click history? Note that this is something that's happening while the user is using the site. It's not historical so much as actionable. Both the speed layer and the batch layer can then tie into a serving layer. This layer is commonly where actual answers are served up to applications and end users. For example, Amazon RDS is a great place to permanently store aggregated data or metrics. Amazon Elasticache is a great caching mechanism that allows you to scale your reporting infrastructure. And of course, Amazon Elasticsearch and DynamoDB are also great data repositories as well. So let's move on from the overall Lambda architecture and talk about some other building blocks when we're looking at our overall design architecture. So some of the other architectures include the multi-stage decoupled data bus. The idea here is that the data arrives in a funnel like Kinesis, and then there's a process that reads from the data store, applies some process to the data, and then moves it into another storage mechanism like S3, for example. This pattern can continue, but the important thing to note is that the data in each storage location is unmodified. For example, the data that comes in through Kinesis is unmodified, and as it comes out of Kinesis and is modified during the processing stage and then stored, we'll say, in S3, the data that's put into S3 is not updated. It's simply modified, and it moves on through the process. If a bus gets stopped for some reason, it will be able to resume once it comes back online. Additionally, if components fail toward the right of the flow, they can be reconstructed by components toward the left of the flow. Multi-stream processing allows for a landing zone like Kinesis to collect the raw data at a very high velocity and then split that stream into multiple streams. This is an extension of the data bus design, as we are in essence creating multiple data buses from a single point of ingestion. This pattern is the basic concept behind what we discussed as Lambda architecture earlier in this presentation. As you can see here that we have Amazon Firehose is essentially feeding into S3, which would be the batch processing layer, and AWS Lambda would be feeding into the speed layer. Building further on our blocks, you can see that we can then attach analysis frameworks to these multiple streams. In this scenario, we have data flowing into Kinesis, allowing AWS Lambda to read from that stream and then populate both an Amazon Firehose as well as DynamoDB. This allows for our EMR cluster to take real-time data from Kinesis using Spark Streaming and then blend that data with historical data in our data lake stored in S3 and DynamoDB to provide us with critical real-time insights. Here we can see a fully realized real-time analytics stack. Moving from left to right, we funnel all of the data inputs into Kinesis. We can then leverage the Kinesis Client library, AWS Lambda, Spark Streaming, or Apache Storm to read the data from the Kinesis stream in real time. Next, we blend that real-time data with historical data stored in Amazon Elasticache, DynamoDB, or RDS, or possibly Amazon Elasticsearch. The blended data can then be fed to Amazon Machine Learning to make predictive analysis of the data and deliver key performance indicators to the business. Additionally, we can send notifications to users via Amazon SNS if necessary. Let's get into the tools. So when we're talking about dealing with a lot of data and looking at either batch processing or streaming processing, it's really important to make sure that we're using the right tools for the job. As you can see on this slide, there are a plethora of tools available to you. The items on the left are open source tools that we commonly see run on top of AWS. If you look to the right, you'll see a number of AWS services that may play a role in your data ecosystem. It's worth noting that the AWS tools listed are managed services. While it's possible to run any of the tools listed to the left on EC2, leveraging the managed services will free you from the overhead of installing, patching, scaling, and otherwise maintaining servers. Sometimes there's a specific technical or business need that requires, for example, we'll say MongoDB to be installed on EC2 rather than leveraging DynamoDB. With that said, though, I would really recommend that you take a close look at what we have to offer with these AWS managed services before deciding to roll your own. Another key point I'd like to make here is that you should strive to decouple the components in your workflow. This allows for much greater application resilience and easier recovery in the event of component failure. And you can think back to the slides we went through with the decoupled data bus, where we had broken the stream apart into multiple different pieces that were all independent of one another. Most of the managed services that we provide were designed specifically to fit into a loosely coupled architecture with this best practice in mind. So, as we've seen previously, there are four main pillars of big data processing. There's collection, storage, analysis, and visualization. We also just went through a whole list of different tools. This slide here kind of illustrates where some of those tools fit. So you can see that we're collecting things on the left-hand side. They're being generated by app servers, web servers, etc. It's being stored in DynamoDB or RDS, S3 or Kinesis. And then that's being analyzed in the middle by Spark, Hive, etc. And so then we have a visualization layer that's all the way to the right. Tableau or QuickSight, which is one of our newer products that is currently in beta and will be coming out in the near future. So let's move on to Amazon Kinesis Firehose. So we've talked a lot about Kinesis and we've talked about Firehose in general, but what is Firehose? So both Kinesis and Firehose are these funnels that you can funnel data in from your applications, from what we call producers. They both have nearly identical APIs. They're very simple. In fact, to write a single record to Kinesis or Firehose, depending on the language you pick, could be as few as 5 or 10 lines of code. It's very simple. One thing that is different about Firehose is that it scales automatically. So you don't have to pre-allocate partitions or shards or anything like that. It can automatically scale to whatever volume that you throw at it. We currently support 3 different targets with Firehose, S3 and Redshift as we talked about, and most recently Elasticsearch. That said, our feature development is driven by feedback that we receive from our customers, and so when our customers come to us and say that they're looking for another target, that's something that we certainly take into consideration, and so I'm quite certain that there will be other targets that will be part of Firehose at some point in the future. Since this is a managed service, there's zero administration. You don't have to install any servers, you don't have to patch anything, and we already talked about scaling. The other nice thing about Firehose is that the data can be put into it in a raw format, and before it reaches its target, it can automatically be batched, compressed, and encrypted before it's delivered. So Amazon Kinesis Streams. So with Firehose, you have the idea of a funnel that will have a target, and the records that are put into that funnel will come out and be delivered to one of the currently supported 3 targets. With Kinesis Streams, the idea is that it's still a funnel and the data goes in there, but by default that data stays in Kinesis so that multiple different readers can read off of it. Kinesis itself does not put data anywhere else. Kinesis itself does not currently analyze any data. It's just a landing zone, and there are a number of different things that will read from that, and you can see from this particular diagram right here that we have 4 different applications that are all reading from a single Kinesis stream. So you can have that single point of ingestion for all of your data and still support multiple readers, and there are no locking issues or anything like that because we're only appending data. There's no concept of an update, only inserts into this data. So Kinesis streams are comprised of shards. So you have one logical stream, and then that stream, like I said, is made up of shards. Each shard can handle up to 1 megabyte per second of input or 1,000 records per second. And each shard can emit up to 2 megabytes a second and have up to 5 concurrent readers. And so what you see here in the diagram is that we've created a Kinesis stream that initially started with 2 shards. And then over time, we realized that we were reaching capacity on those shards. We were going to start taking in, we'll say, 2,500 records per second. And so we've split those shards, and we now have 3 shards. And then later, we dropped that back down by doing a merge operation, and we're back down to 2 shards again. And so the Kinesis streams can be expanded or contracted to carry what it is, whatever load it is that you're sending to it. The data by default, when it's written into a Kinesis stream, will be kept there for 24 hours on a sliding window, so it will age out automatically after 24 hours. But recently, well, I guess it's reInvent, it's been a few months now, we've extended that for up to 7 days. And that's a configurable property, but by default, it's 24 hours. To scale Kinesis streams, you can use the scaling utility, which we're going to talk about here in just a minute. And then you can replay that data inside of that 24-hour window as many times as you want to as many readers as you'd like. So when we're talking about Kinesis Firehose versus Kinesis streams, we kind of went through this, but the streams, they're both landing zones, but the stream is specifically meant for a variety of different readers that will read that data and do various things with it, possibly put it into a lot of different targets, whereas the Firehose is more specific to delivering that data in a controlled manner into one of its targets. A great example is Amazon Redshift is our data warehouse. And for those of you familiar with data warehousing, you don't stream records into a data warehouse. It doesn't work well. And so with Firehose, your application can stream data effectively to the data warehouse via Firehose, and then Firehose will batch those records and then will load those records automatically into Redshift in a best practices manner so that you don't have to worry about partitioning or any sort of partition sliding windows or anything like that. So streaming data ingestion. So let's talk about when you're actually putting data into a Kinesis stream. Now remember, we're talking here specifically about the Kinesis streams and not about Firehose. With Firehose, you just pour the data in there and it will end up in the target that you have deemed your goal. So with Kinesis streams, you need to determine your partition key strategy. When records are put into Kinesis, you can specify a partition key. And what that partition key is will determine which shard it goes to. So you want to know, am I doing a managed buffer, or am I for streaming for a MapReduce job, or do I want, and then I want to make sure that I have a high cardinality for my shards. We want to make sure that we provision enough shards for our ingress needs. And then sometimes, if you have a certain number of records that are coming in, but you have a lot more readers, then you can allocate additional shards, and even though they won't be saturated on writes, it will allow you to scale for reads. So whether you need to scale for reads or writes, you would do so by adding or subtracting those shards. And you want to make sure that you include a little bit of headroom for catching up with data in the stream. So that means, once you bring the stream online and you're writing data to it, and then you're going to have a consumer connect to that shard and start reading from that shard, that if it's not at its peak, if it's not 100% full on its writing throughput, then it would give it a little bit of time to catch up. So we have a few tools that you can use to augment your Kinesis experience. The Amazon Kinesis agent allows you to write data directly to Kinesis. It can listen to files in your file system, and as those files, the data changes in those files, it will read that automatically and pump that directly into Kinesis for you. And then you can do pre-batch before puts. So if you have, we'll say it's a very small example, but you have 1,000 records, it's much better to put those into one batch put operation than it is to make 1,000 individual put operations. It will greatly reduce your latency and maximize your throughput. And then you might want to make a tweak to some of your existing logging as well. Use log4j appender, or you might want to use Flume or FluentD as collectors or agents as well. So the Amazon Kinesis Producer Library. So this is a tool that allows you, so we're talking about producing records to put in there. It will allow you to write to one or more Amazon Kinesis streams, and it will automatically handle retries. It collects the records and puts those records and uses put records to do multiples, because remember we were just talking about batching up those records before we put them into the Kinesis stream. It'll aggregate user records to increase the payload size and improve throughput, and it works with the KCL to deaggregate batched records on the other side when you're reading the records out. The Amazon Kinesis producer library now works with AWS Lambda. There's a library that you can include with your Lambda functions that will allow you to read the aggregated records. And then it also works with Amazon CloudWatch so that you can watch metrics to get some visibility into the producer performance. So record order and multiple shards. So the records, when they come in, are ordered in a given shard. So in a given stream, there's not a FIFO ordering, but within a given shard, there may be. So you want to think about, what am I trying to accomplish here? If the goal is to put in as much data as you can, then you want to make sure that you randomize the partition key, because that will allow you to spread those records evenly, for the most part, across all of the shards and maximize your throughput. If it's more important to, say, control the exact ordering of the records as they're going in, then you want to make sure that you use the same partition key for like records, so that all of the records that are associated with one thing will go to one shard. If they're associated with the other thing, they go to a different shard. If you need both, you can use a global sequence number. Here is some sample code for scaling shards. With Firehose, this happens for you automatically. There's no consideration that needs to be given to shards or scaling, but it's also not very difficult to scale shards here, just using this tool that's already been developed. And you can see there's a link to it on GitHub, so you can download the source code for it and deploy it easily. So Amazon Kinesis Stream processing. So we've talked about the producer library. We also have a client library. The Amazon Kinesis Client library allows you to build KCL applications. This is sort of the starting point for consuming from a Kinesis stream. You can use the low-level APIs, and that will work fine, but the KCL will take care of a number of other things for you. It's an open source client library available in Java, Ruby, Python, and Node.js. You would deploy it on EC2 instances. So it gets a little bit away from the unmanaged, from the managed sort of use case, and is more of something that you need to manage, but it's still very powerful. The KCL application includes these three components: the record processor factory, the record processor, and the worker. So the KCL leverages DynamoDB to keep track of checkpoints. So as it's reading data out of a stream and it needs to keep track of where it is in the stream and its position, excuse me, it will store that information in DynamoDB. So that's something to be aware of while you're using the KCL. So there are other options. There are a number of third-party connectors. There's an example of Splunk that can just connect right up to your Kinesis stream and just read the data directly from your Kinesis stream. The AWS IoT platform also integrates nicely with Kinesis. AWS Lambda, which we'll talk about here in a minute, and Amazon EMR with Spark, Pig, and Hive. So, once we have this data that's streaming into our Kinesis stream, something that will allow us to read that data in real time is to leverage Spark. So Spark is an in-memory analytics cluster, and it uses RDD for fast processing. And Spark Streaming can read directly from the Kinesis stream. There's actually a Spark Stream component that you can use that lets you read directly from that Kinesis stream as the data is being written. You can see at the bottom there's a very simple example of how to leverage that Spark stream in order to read directly from, in this case, it looks like a Twitter stream. Common integration pattern with EMR. So we've talked about a lot of different architecture components earlier. Here we have the Kinesis stream where the data is being poured into the funnel, and then we have Spark, which is running on Amazon EMR, and that is reading that data in real time from that Kinesis stream And then sometimes it will perform a copy operation into Redshift or do whatever else it needs to do with it. Because remember, you can have multiple readers. We'll say perhaps one that's reading in real time from that Kinesis stream and reacting, and then we have another one that is taking that data and batching it and putting it somewhere else like Amazon Redshift. One of my personal favorites is the AWS Lambda. So with Kinesis streams, you can write a Lambda function, and just a quick bit of background on what Lambda is, if you're not familiar. Lambda is the ability to write a function, a simple function in either Python or Java or Node.js, or currently the languages that we support. And then you can then take that function and attach it to an event. And there are a number of events that span a wide variety of our services. But as it pertains to this particular case, you can take a Lambda function and attach it to a Kinesis stream. And so what happens is that you have applications that are writing to that Kinesis stream, and they're hitting those shards, and then AWS Lambda will respond to those shards and process the data for you. So earlier we had talked about using the Kinesis Client library, or KCL, which runs on top of EC2. It's great, and it works exactly how you need it to, but you still have to manage EC2 instances, and you still have to pay for underutilized CPU resources. So it depends on how highly utilized your KCL clusters are, but AWS Lambda is oftentimes a great fit. So this is sort of a picture of what it looks like. We have these producer applications that are funneling data into this Kinesis stream. In this case, the stream is comprised of 5 different shards, and that means it will need 5 different consumer applications that are all running, because the consumer applications will each read from a specific shard, so that they make sure they're not stepping on each other's toes as they're processing the data. This diagram here can be simplified into this, where instead of the KCLs, we have a Lambda function. And so you write the one function, and then in this case with our 5 shards, that Lambda function has 5 parallel execution paths. Think of it as, in this case, we'll say 5 different threads. So we have that same Lambda function running in parallel on all 5 of those shards. And again, this is no EC2 instance to manage. You simply specify, this is the code that I want to execute, this function. That function receives as input a list of records that have been read off of the stream. You can specify it up to 10,000 records in a given batch size, and then you can do whatever you like with that. And we'll go through that and look at a Lambda function here in a few minutes. And speaking of which, we're going to move to the demo right here, and we're going to take a look. This is the demo that we've built. We're going to primarily focus on the Lambda and the Firehose, Redshift, and S3 component of this. Okay. So let's take a look first at our Kinesis stream. Click on Kinesis, and it's very simple. I mean, I can't emphasize enough how simple it is to set up and work with a Kinesis stream. In this case, we have one that's called log stream. We've allocated 2 shards, so that means that we'll be able to handle up to 2,000 puts per second into our stream. And let's take a look at that and see how it's doing right now. So right now, just looking at this is sort of a brief glance at what's going on. It looks like we have just a little under 1,000, but I put 2 shards in there so that if there is a peak in our load, that it will be able to accommodate that. You can see the put latency over here is hanging steady right around 7 milliseconds. The get latency is how long the latency for, in this case we're using Lambda to read from this stream, the latency for pulling those records off of that stream. You can see we're running it right around, it looks like about 1,200 get requests per second. And so let's take a look from here into CloudWatch. So I've set up a couple of dashboards here, and these are some of the key performance indicators for Kinesis in general. So right here we're looking at the put record latency, and this is for the an average over the past 3 hours for aggregated into 15 minutes. So it's pretty steady. I mean, we can see that the bottom is around 7.2, the top's 7.34. So it's very consistent performance that we're getting out of there. Same with the get records latency. Right here we can see the incoming records per minute. We're looking at about around 50 to 55,000 records per minute coming into the stream. And then you can see that the get records is matching almost identically. And remember, I said we're using Lambda to process this. So what this is saying to me is, since these two map so closely, that we are very close. We're processing that data in real time. It's being read almost as soon as it's being written to it. The iterator age right here is another important thing to look at. What the iterator age specifies is it says, as you're reading from Kinesis, what is the oldest record that has not been read yet by all of your readers? And so this gives you kind of a feel for, how far behind your readers have become. So it looks like in the past 3 hours we had one blip where we were at about 4 seconds. About 4 milliseconds behind. Otherwise, we're reading them just as fast as they're coming in. So how do we generate all of this traffic? Talk about that really quickly. It's a little bit outside of the scope of this, but I thought it's worth mentioning. It's just a simple Python script. This Python script spins up a number of threads, and it's just generating random data that it's pumping into that Kinesis stream. We then took that script and we launched it with a bootstrap script that simply downloads that Python script and then runs it, and then if there's an error, it will shut the instance down immediately. So looking at the design of this, you remember, if you look back at the slide, that the data is coming into this Kinesis stream, and then we have Lambda functions attached to it. Now, we could have a single Lambda function that's attached to that Kinesis stream that's populating both the firehoses for Redshift and for Lambda, but we decided to break those apart because we'd like to keep things loosely coupled, as we discussed earlier. So let's take a look at the Lambda functions. So we have 2 of them here, and we'll start with this log Lambda. This is the one that's writing to S3. So we'll walk through the code briefly. So we have some of our basic imports up here, and then we define the delivery stream name. We create a Firehose client, and then this right here is the function. This is a common component of all the Lambda functions. They all have the same type of signature with an event and a context. And in here, we're going to specify this record buffer that we're going to accumulate records in, and then we will print out to the end user how many records we're going to process, and we loop through them, and we build out this payload. So it's worth noting here, what we're doing is we're doing extract by extracting the records out of the stream. We're performing a transform here, because in this case we'd like to append a carriage return and line feed to the end of each one of the records because it's getting ready to go into a file in S3. And then we're doing a load by putting that batch of records into Firehose. Firehose has a limit of 500 records per put, and so since Kinesis will take in 10,000, we're just looping through and making sure we have at least 500. Once we exit the loop, if we still have any records left in the buffer, we flush them out to the Firehose, and then we return. So a couple of other components to point out about this. So you can specify the runtime, Java 8, Node, or Python 2.7. The handler is the name of the function, the entry point into the code. The role, this is how you define what the permissions are that can be applied to the code as it's running. So for example, if your Lambda function needs to access another AWS component that requires an IAM role, it's a lot like EC2 roles, where it will authenticate you and authorize you as necessary. And then you can put in a description. But this right here is a very important part. This part where it says memory, you can specify this from 128 up to 1,536 megabytes. And so that is the number, that's the amount of memory that's allocated to your function to run, but what's also allocated is a proportional amount of CPU power. And then you can specify a timeout. And so the cost for this is based on how many executions you've had and how long it's run and how many megabytes. So I did a little bit of work with this, and I set it initially at 128 megabytes, and it took my Lambda function about 10 seconds to complete. And then I set it at 1.5 gigs, and it took about 3 seconds to complete. And so then I kind of went through that and found sort of a sweet spot right at 256, where I got a nice trade-off in the performance, the speed, without reaching the diminishing point of return by maxing it out at 1.5 gigs. Another thing to note here is this VPC. In our particular case, since we're feeding this directly into Firehose, we don't need access to VPC. But let's say that, for example, you were, instead of putting this into Firehose, you got the records and you transformed them somehow and you wanted to put them into, say, RDS, maybe an Aurora database. Well, then here is where you would enable VPC access, and then your Lambda function would then have connectivity access to other resources that are inside of your VPC. The event source right here, you can see we've specified 10,000 rows. The last result was okay. It's currently enabled. You can disable it. API endpoints are not pertinent to this particular discussion, but the monitoring is something that's important to look at. And so you can see how your Lambda function is performing generally over time. So let's take a look. We've gone through Lambda, and so let's take a look over at Firehose and see how Firehose is holding up. Under Kinesis. So just to recap, a single Kinesis stream, 2 Lambda functions on that same stream. They're feeding into 2 different Firehoses. We'll take a look at the S3. These are all the things that you need to specify to build out your Firehose. It's very simple. A name, an S3 bucket where the files will be delivered, a prefix if you choose to put one, the role that needs to have permissions to allow you to put that data there, and then you can specify the S3 buffer size. And so you can say, I would like, in this case, my files to all be 100 megabytes in size. However, if I don't reach 100 megabytes in size after 60 seconds, then we're going to go ahead and flush the buffer anyway. That means that the data that I have will never be any older, any more stale than 60 seconds. We're not going to compress it, though we have several options to, and we're not going to encrypt it, though we could do that as well. All right, and then take a quick look at the Redshift. Redshift is very similar. It has the same parameters on the left, but you can see that we also need to specify the Redshift cluster, the database, the table, the Redshift columns, etc., and a few other things. So for example, one of the things that we're loading is a time field. So we needed to specify, as part of the copy command, the time format so that it could be imported correctly. So what is the speed with which all of this is being loaded? We'll take a look here. We'll connect to our Redshift cluster. Oh, well, it looks like we ran into a problem with that, so we will pass on that. But I will tell you that during my testing and analysis before this, the Redshift cluster, and as we discussed, Redshift is a data warehouse. Usually you wait hours at least between loads into a data warehouse. The data that was being loaded into the timestamp on the records that's generated on the client that's producing the records was lagging anywhere from 7 seconds up to about 45 seconds behind what the current time was on the Redshift cluster. So that means that our Redshift cluster is a data warehouse is being updated in less than a minute, and is close to real time as you're going to get with the data warehouse. And so that is all that I have for this part of the session, and I think we're going to switch it over to some Q&A.
Okay, thank you, Steve, for a great presentation. and Guy, Jorge, and Prahlad for engaging with our audience throughout the presentation. On the left side of your screen, you'll see 3 live poll questions. Please click on the radio button next to your answers for each of those poll questions to give us your feedback. We have about 13 minutes left, so feel free to continue submitting questions. We will start addressing some of them that have been submitted, and we apologize in advance that we might not be able to get to all of them. Steve, I'd like to hand it back over to you.
Okay, thanks, Ryan. So I have a question here. It says, how do I ensure that a customer always writes to a particular shard and a consumer reads from the same shard? Using partition keys only ensures that it goes to a particular shard. How do consumers consume from the same shard? So the idea behind Kinesis is that it can scale out and scale in, right? And so when you're doing that, you don't want to really rely on the identity of the shard that you're writing to, because when you do a split and a merge, those shards, so for example, let's say you have 3 shards and then you do a merge, that third shard will become, I forgot the term for it, but it will become essentially dead until the data, it will remain there and it will be readable until the data in that shard is expired and falls off, but that shard will never exist again. And so depending on the specific shard IDs is generally not a great idea. Let's see, what else do we have here for questions? So here's a question that says, how do I drive Spark Analytics on DynamoDB? Is there a connector that allows me to create a data frame from DynamoDB data? So you can use Apache Spark on EMR to analyze the data stored in DynamoDB. And there's a nice blog post that provides some additional details. Let me see if I can post that out onto the Q&A. All right. So here's a question that says, how do we guarantee the availability of Kinesis to other readers? Do we have any failover backup methodology in place? And so, the availability of the Kinesis shards, which are, the buffer that is storing the events, it's the funnel where everything is being poured into. They're designed already for high availability and durability, because when we run Kinesis, we run it across multiple different availability zones. Just to kind of rewind and recap, we have these regions that are all around the world, say Virginia, Oregon, Frankfurt, Tokyo, etc. In a given region, we have multiple distinct what we call availability zones, which are clusters of data centers that are on different floodplains, different electrical grids, and they're generally physically isolated from one another, so that in the event one were to go down, then the other ones would remain online. With Kinesis, since we spread our load across multiple availability zones, it ensures that we have a high degree of durability and reliability. Let me see, what are some other questions that we have here? So from a security standpoint, how do clients authenticate with the Kinesis before pushing the data to the stream? So there are a number of ways. One way, right out of the box directly, is to use AWS Identity and Access Management, and you can create appropriate permissions for your applications. You can also use STS, or Simple Token Service, if you want to temporarily grant permissions to a given user or service to write to a Kinesis stream. And then another way, too, is you could leverage the API gateway. And we touched on that very briefly earlier, but one of the things the API gateway can do is allow you to define your own custom REST-based interface, and you can attach that to a number of AWS services, and they will proxy those requests. And since API gateway has different authentication mechanisms built into it, you can proxy them through the API gateway. So there are a number of different ways that you can secure your Kinesis stream. So here's another question. says, if I have a producer application deployed on site at a customer's data center, how can I make sure that the firewall allows for writing to a Kinesis stream? So what you need to do, so writing to Kinesis, it happens at the lowest level. It makes REST requests into the Kinesis service. So you want to make sure that your firewall can write to, secure. You can write HTTPS over port 443 to the Kinesis endpoints. And you can find a list of all of our endpoints, including the Kinesis endpoints, on the AWS website. And so you just want to make sure that your applications have access to write to those endpoints. So here's a question that says, how many Lambda functions running concurrently is allowed by AWS, since default is 100 concurrent initially, so Kinesis streams will quickly overwhelm the limit. So 100 is a limit, but it's a soft limit. It's something that can easily be raised by creating a support ticket. The reason that we put that there and why we put a lot of our soft limits in place is really to protect the customer, so that you don't have a runaway process or a runaway anything that all of a sudden you wake up one day and you have an enormous bill. So it's something that we can easily adjust for you, but it's, if you were to have 100 concurrent Lambda functions executing on, we'll say, a given stream, that's a lot of data that's coming through there, because you remember each one of those Lambda functions is supporting a whole stream, which is 1,000 puts per second. It's something that we can easily address. So here's a question that says, does Amazon have any recommendations with log file streaming and analytics? Is Kinesis, Lambda, and SNS good choices for a log streaming use case, or do you have other recommendations? And so, Kinesis in the Lambda approach can be one of the choices for log file streaming. There are other architecture options like Kinesis with Elasticsearch, Kinesis with Redshift, or even integrating Kinesis with a partner solution like Splunk. And we kind of went over, a few of those different options. And, Firehose is a great thing to use for logging, especially, since it can specify a target as S3, a great place to put your logs. If it's, Elasticsearch or Redshift, those are obviously two other choices as well. So here's a question. It says, what distinguishes Kinesis from Kafka beyond being Amazon software? So there are a number of differences between the two, but one of the main things that I think is really important is that it's a managed service. So, we don't have anything against Kafka. Kafka is great, and like I said about the example earlier about possibly using DynamoDB and Mongo, maybe you have some specific use case for that. But in most cases that I've seen, in my experience, if there's an option to use a managed service, it's much preferable. Kinesis, in order to set up a Kinesis stream, it takes a few clicks of your mouse, and it's up, and it's redundant, and it's highly available right out of the gate. If you want to run Kafka, well, then you would need to create an Amazon machine image that has Kafka on there. You'd have to build auto-scaling groups. You'd have to deploy it, manage it, maintain it. And the other thing about Kinesis as well is it's very inexpensive. We talked about the shards. The shards come out to a little over $11 a month for a shard. So by my estimation, given the price, given the speed and ease with which you can set up a Kinesis stream, and given the built-in durability and availability of Kinesis, 9 times out of 10, my preference would be for a Kinesis stream. So here's a question. Can Kinesis Replay be done from any particular offset like Kafka? So you can use the KCL along with DynamoDB to keep track of where you are in the stream. You know, at the lowest level, like I was saying earlier, you can use the API and just crack open the stream in a shard and just start reading from it. And there are sequence numbers in there. There is a mechanism to keep track of where you are in the stream. And so the KCL generally, well, it always does keep track of that in DynamoDB. But it's something that can be done either with KCL, it can be done manually. If you're using Lambda, something important to note about Lambda on Kinesis is that Lambda will execute with a batch of records, and if the function returns successfully, it will increment to the next batch of records. If it does not complete successfully, it will retry those records until either it's successful or that data falls off of the Kinesis stream. So here's one. It says, is Kinesis primarily, and this is the last question for today, by the way, because we're running up on time. Is Kinesis primarily for landing streaming data at scale? Yes, it's for landing data at scale, and it's also for reading at scale. So setting up a Kinesis stream, it is that funnel where you can pour as much data as you can generate into that stream, and you don't have to worry about it being lost. It's all there, it's redundant, it's durable. And then the other side of that is to be able to read from that. So you can have as many readers as you want. You're only limited by how many shards you allocate. So if you have 1,000 readers, then you would just need to make sure that you have enough shards to read from that. It is a funnel for you to pipe data into it and then read the data back out of it. So that's it for the question part today. So I'm going to hand the controls back over to Ryan. Thank you everybody today for your time.
Great. I'd like to extend a special thank you to our presenter Steve for his time and a great presentation, and also to Guy, Jorge, and Prahlad for answering your audience's questions. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks again to you guys, our audience, for taking time to join us today, and enjoy the rest of your day.